Hello students and good morning. So now I'm doing class for class 12. The topic is the same topic that we were doing in the last online class. That is your binary operation. I hope. So you have revised. So I hope you have revised all the problems that we did so far in this chapter, binary operation. Okay. So now we'll do exercise 3B, page number 65. Okay. So this is question number 10. So here question number 10 is let X be a non-empty set. The X it is a set. It is a non-empty set. So since it has got some elements, so this X is taken as non-empty sets. And star be a binary operation of P of X. P of X is the power set of X. So what is the meaning of power set of X? That you should know it. Okay, now first of all, let me explain about power set of X. So what do you mean by power set? Okay, suppose if you have, capital X is the set of elements 1, 2, 3. Suppose capital X contains the elements 1, 2, 3. That is, X is a set which contains some elements 1, 2, 3. So, यसको power set भनेपछि के हो भन्दाखेरि the set which contains all these subset of X is known as what? Power set of X. The set which contains all these subsets of X is known as the power set of X. Okay. So what is the meaning of subset first then? Subset भनेको के हो? The subset भनेको तिमीलाई राम्रोसँग याद छ. Subset भनेको के हो भन्दाखेरि suppose A is equal to 1, 2. अच्छा X र Y नै लियौं. यहाँ X को कुरा हुँदैछ, त्यही कारण X र Y नै हामी लिन्छौं. Suppose X is equal to 1, 2 छ अरे. Suppose X is equal to 1, 2. अनि Y is equal to छ अरे 1, 2, 3, 4. Right? So here capital X is equal to 1, 2 and Y is equal to 1, 2, 3, 4. So in this case, this capital X is known as a subset of Y. What do you mean by is a subset of Y? X is a subset of Y. That is, every element in the set X is also an element in set Y, isn't it? So you 1 र 2 X मा पनि पर्दैछ, यो 1 र 2 Y मा पनि पर्दैछ. So every element in the set X is also an element in the set Y. So in this case we say that X is a subset of Y. In this case we say that X is a subset of Y. But in this case we can't say Y is a subset of X because there are two elements 3 and 4 in set Y which do not belong to the set X. So Y is not a subset of X. Okay? But 1, 2, both these elements belong to the set X. Also 1, 2 belongs to the set Y. So in this case we say that X is a subset of Y. Is that clear? So now suppose X is equal to 1, 2, 3 is there. Okay. So now in this case, this one is also a set. Okay. This within second bracket 1, second bracket is closed. हामीले यो second bracket भित्र लेख्दा चाहिँ यो केमा आयो? Set भइगयो अब यो. This is one of the sets. Is that clear? This is one of the sets. This within second bracket 2, this is a set. यदि कुनै पनि elements लाई हामीले second bracket भित्र close गर्यो भने त्यो केमा आउँछ? एउटा set मा आइगयो. That is, since within second bracket 1, 2, 3 is a set and it is denoted by X. So 1 is a set, it can be denoted by A or B like that. This within second bracket 2 is also a set. This 3 is also a set. Okay. So here 1, 2 is also a set. Here 2, 3 is also a set. 1, 3 is also a set, and 1, 2, 3 is also a set, isn't it? So that is, this within second bracket 1 is a set. This is a subset of X, isn't it? Is that clear? This within second bracket 1 is a subset of this X. This within second bracket 2 is a subset of X. So this one belongs to a set and this one also belongs to the set X. So within second bracket, suppose if you denote it by A is equal to within second bracket 1. This is a set. So here A is a subset of X, isn't it? Here A is a subset of what? X. Because this one is an element of A and also one is an element of X. So here we say that A is a subset of X. That is, every element in the set A is also an element of the set X. So in this case we say that A is a subset of X. That is, within second bracket 1 is a subset of within second bracket 1, 2, 3 or X. Is that clear? This within second bracket 2 is also a subset of X because this is a set. Within second bracket लेखेपछि के हुन्छ 2 set मा आइहाल्छ. So within second bracket 2 is also a subset of X. Within second bracket 3, this is a set. This 3 is also a subset of what? X. Is that clear now? Now within second bracket I have written here 2 elements. This is also a set because this is the collection of some numbers. So this is a set, isn't it? So this 1, 2 is also a subset of X. Similarly, this 2, 3 is also a subset of X. 1, 3 is also a subset of X. This itself, this set is also a subset of X. So 1, 2, 3, this is one of the set and this also belongs to the set X. That means 1, 2, 3 is also a subset of X. Is that clear? And you know that phi is empty set. So you know that empty set is a subset of every set. We know that empty set is a subset of every set. So यो चाहिँ तिमीले याद गर्नुपर्छ. Empty set is a subset of every set and this empty set is denoted by phi. So this is also known as null set or void set. जुन चाहिँ सेटमा चाहिँ कुनै पनि एलिमेन्ट्सहरु हुँदैनन् त्यसलाई चाहिँ हामी के भन्छौं? एम्प्टी सेट भनेर भन्छौं. त त्यो एम्प्टी सेट void सेट पनि हो अर्थात null सेट पनि हो. ठीक छ? So empty set is a subset of every set. Okay? So this phi is a subset of every set. Okay? So यो phi लाई पनि हामी यहाँ include गर्न सक्छौं. This phi is a subset of X also. This phi is a subset of X. Okay? So all these possible sets, that is phi, then comes 1, isn't it? 2, 3. All these are possible subsets of X, isn't it? Right? That is, if you have capital X is equal to 1, 2, 3. So you can write phi because empty set is a subset of every set. Okay? So यो X मा एउटा subset के हुन्छ? Phi पनि आउँछ. एउटा subset कति भयो? Within second bracket 1. अर्को subset 2 निकाल्न सक्छौ. अर्को subset 3 निकाल्न सक्छौ. अर्को subset 1, 2 आयो. अर्को subset 2, 3 आयो. अर्को subset 1, 3 आउँदैछ. अर्को subset कति आयो? 1, 2, 3. So all these subsets, all these possible subsets are the power set of X. यो जति पनि यहाँ possible subsetsहरु छन् त्यो सबैलाई हामी के भन्छौं? पावर सेट अफ X भनेर भन्छौं. त यो एउटा एक्जाम्पल भयो. अब म अर्को एक्जाम्पल दिदै छु. सो यो चाहिँ पावर सेट चाहिँ के हो त्यो विषयमा हामी सिक्दै छौं. त पावर सेट चाहिँ के हो म त्यो बुझाउने चेष्टा गर्दै छु. लेट अस टेक अनदर एक्जाम्पल. अलिक सजिलो एउटा एक्जाम्पल लियौ. Suppose you have capital X is equal to within second bracket 1 मात्रै छ अरे suppose. So what are the possible subsets of this set X? यो set X को possible subsets हरु के हो? what are the possible subsets of X? You know that this empty set is a subset of every set, and now this one only within second bracket 1 is there. This within second bracket 1 is also a set. कुनै पनि नम्बर तिमीले यो कर्ली ब्रैकेट अथवा यो सेकेन्ड ब्रैकेट भित्र हाल्यो भने त्यो के हुन्छ सेट भइहाल्छ. That means this is also a subset of X, isn't it? That means it is a subset of X. तो यो X सेट को अर्को एउटा सेट आयो, अर्को एउटा भाग आयो. That is, this within second bracket 1 is also a subset of X. So what are the possible subsets of this set X? One is phi and other one is within second bracket 1. Is that clear now? And it is denoted by what? P of X is equal to यसलाई फेरि यसरी सेकेन्ड ब्रैकेट भित्र हाल्नु. त px पनि सेट हो नि त, तर त्यसलाई चाहिँ हामी के भन्छौं? पावर सेट भनेर भन्छौं. That is the set of all possible subsets of the given set X is known as the power set of X. Is that clear? So let us take another example. Suppose you have two elements, capital X is equal to 1, 2. So what are the possible subsets of this set X? Okay, so one is phi, because empty set is a subset of every set, and the other one is, you have to take this individually. That is, within second bracket you can write 1, within second bracket you can write 2. This second bracket 1 is a subset of this set 1, 2. This within second bracket 2 is a subset of within second bracket 1, 2. Ani तिमीले के लिनु सक्छौ? Within second bracket 1, 2 is also a subset of 1, 2. Okay, so these are possible subsets of the set X, and it is denoted by P of X. Is that clear? So okay, हामीले तीनटा एलिमेन्ट को दियौं हैन? त तीनटा एलिमेन्ट को जस्तै क्यापिटल X is equal to 1, 2, 3 छ भने यसको possible subsetsहरु के हुन्छ? एउटा phi भयो. Always you have to take phi, okay? Because empty set is a subset of every set, okay? Then comes within second bracket only one element. Then again within second bracket 2. Again within second bracket only one element is there, 3. This is also the sets. But these are the subsets of X, okay? हामी यो सब पार्ट भन्छौं नि. जस्तै क्वेशन नम्बर 1 मा छ. क्वेशन नम्बर 1 मा के लेखेको हुन्छ? त यो क्वेशन नम्बर 1 को फेरि सब क्वेशन्सहरु हुन्छ. जस्तै A, B, C. यसलाई चाहिँ हामी के भन्छौं? सब नम्बर भनेर भन्छौं. सब नम्बर, सब पार्ट or sub part. A is the sub part of 1, B is the sub part of 1, C is the sub part of 1. Or it is also known as number A is the sub number of number A, B is the sub number of 1, C is the sub number of 1, like that. Okay? So now in this case, what are the possible subsets of the set X? One is phi within second bracket 1, within second bracket 2, within second bracket 3. These are the subsets. Again, you can take within second bracket 2 elements. Again 2, 3. These are the possible elements. And again you can take 1, 3. Again you can take all these 3 elements within second bracket. That is 1, 2, 3. Is that clear? So this is power set of X. This is known as power set of X. So I think you have understood it. So if a set contains only one element, if the set contains only one element, so how many elements are there in the power set of X? The formula is there. If the set X contains only one element, right? If the set X contains only one element, then power set of X contains 2 elements here. Okay? If the set X contains 2 elements here, how many elements are there in the power set of X? It is 4 elements are there. And if the set X contains 3 elements, So how many elements are there in the power set of X? 1, 2, 3, 4, 5, 6, 7, 8. So there is a formula here. Okay, the formula is if the set X contains n elements, if the set X contains n elements, X ma n elements haru chan bhane, power set of X contains 2 to the power n elements. यो पनि याद गरिराख्नु. त यो क्वेशनमा हामीलाई यो त चाहिँदैन र पनि याद गरिराख्ने. If the set X contains n elements, then the power set of X contains 2 to the power n elements. Okay? So here this X contains only one element. And this power set of X, so how many elements are there in the power set of X? It is 2 to the power 1, which is equal to 2 elements. Is that clear? I think you have understood it. Suppose if this X contains 2 elements, then power set of contains number of elements is equal to 2 to the power 2, isn't it? What is 2 to the power 2? Which is equal to 4 elements are there. Okay? If the set X contains 3 elements, suppose this set X contains 3 elements, how many elements are there in the power set of X? It is 2 cube. 2 cube means 8. That is 1, 2, 3, 4, 5, 6, 7, 8. So I think you have understood it. So what do you mean by power set of the given set X? That is the set of all possible subsets of the given set X is known as the power set of X. Is that clear? What do you mean by power set of X? The set of all possible subsets of the set X is known as the power set of X. So I think you have understood it. So let us write down the definition of power set. Now let us write down the definition of power set. The power set of X is the set of all possible subsets. The power set of capital X is the set of all possible subsets of the set X. Okay? So what is meant by power set? The power set of capital X is the set of all possible subsets of the set X. Okay? So now let us take an example. Suppose capital X is equal to 1, 2, 3 is there. Okay? So what is P of X? What is P of X? P of X will be the set whose elements are the subsets of the elements of X. Okay? Whose elements are the subsets of the set X. Is that clear? So P of X means power set of X. So how can you define power set of X? Power set of X, the power set of X is the set of all possible subsets of X. Okay? So here ke lekhchau? This is one of the set is phi. Phi is a subset of every set. Then comes this within second bracket 1 is a subset of X. This within second bracket 2 is a subset of X. This within second bracket 3 is a subset of X. So within second bracket, take the elements in pair now. 2, 3, then 3, 1. Or you can write 1, 3 or 3, 1. Same thing, right? Then comes 1, 2, sorry. This is within second bracket 1, 2, 3. So how many elements should be there? 2 cube. 2 cube means 8. 1, 2, 3, 4, 5, 6, 7, 8. So these are the definition of power set of X. So I think you have understood power set. So for this problem, you should know the meaning of, or you should have the knowledge of power set. So I think you have understood it. Okay. So let us do this question now. So now let's do this question now. let capital X be a non-empty set. But if see there are some elements in the set X, okay, and star be a binary operation on P of X. P of X means the power set of X. It is defined by A star B is equal to A intersection B for all this A comma B belongs to the power set of X. You A comma B से कहाँ पर्यो? Power set of X मै पर्दैछ. ठीक छ? So now you have to find out number 1. Find the identity element in P of X. Find the identity element in P of X. And number 2 is you have to show that this capital X is the only invertible element in P of X. So I think I want to study it. So here given is Px is the power set of X. Px is the power set of X. Px is the power set of X, right? So now, so star is defined as what? A star B. A star B is equal to A intersection B. So A star B is equal to A intersection B. Okay? A star B is equal to A intersection B. Right? So now in this case, A intersection X is a non-empty set, right? So let E be the identity element. Let E be the identity element. Let E be the identity element that belongs to the power set of X. Let E be the identity element, that is E belongs to the power set of X. So we know that by definition A star E is equal to E star A is equal to A. Is that clear? Next, or now in this case A star E is equal to A. Either you can write this A star E is equal to A or E star A is equal to A. Okay? So यो E को value चाहिँ कति हुनु पर्यो त so that A star E is equal to A. तो यो E को value चाहिँ के हुनु पर्यो? X नै हुनु पर्यो. Isn't it? यो E को value चाहिँ के हुनु पर्यो? X नै हुनु पर्यो. That is A intersection X is equal to what? A. So A intersection your E को value is के हुनु पर्यो? X, where X is the non-empty set. Okay? So A star X is equal to के हुनु पर्यो? A नै हुनु पर्यो. Because in this case, suppose X is equal to, X is the power set of A, isn't it? So let us take an example. Let us take an example. Suppose, just I am giving you the example, okay? How is it A intersection X is equal to A? Suppose we have X is a non-empty set, that is it is 1, 2 is given. 1, 2 is given, right? So now we have to find out power set of X. So what is P of X is equal to? What is P of X is equal to? What is P of X is equal to within second bracket? It is phi 1, this is 2, and this is your 1, 2. Second bracket is closed. This is the power set of X. Is that clear now? So next we have here, now suppose A is equal to, suppose A is a set, suppose A is a set 1. Suppose A is only 1. Okay? So what is meant by A intersection X? What is meant by A intersection X? I am just giving you the example, okay? Don't copy this one. A star E is equal to A star X is equal to A. यहाँसम्म एकदम ठीक छ. अब मैले यो बुझाउन खोजेको A intersection, sorry, A intersection X is equal to A चाहिँ कसरी आउँदैछ त? Suppose let us take an example. Capital X is equal to within second bracket 1, 2 is there. Okay. So what is P of X? What is power set of X? That is every subset of X will be the power set of X. That is phi 1, 2, 1, 2, isn't it? So let us assume that A is equal to this within second bracket 1. Okay. So what is A intersection X now? So A भनेको कति भयो? This is your 1 intersection within second bracket. What is X here? It is 1 comma 2. It is 1 comma 2. So which is the common element out here? Which is the common set out here? This is 1, isn't it? So here this is your 1, which is equal to A. That is A intersection X. Intersection भनेको चाहिँ common elements हरु हुनु पर्यो or common set हुनु पर्यो यहाँ, किनभने A र X त दुईटै के हो? सेट हो नि त. ठीक छ? त यो A र X चाहिँ दुईटै सेट भएको कारणले गर्दाखेरि यो 1 is a set out here. So A intersection X is equal to within second bracket 1 intersection within second bracket 1 comma 2. त यो दुईटामा कुन चाहिँ सेट चाहिँ कमन छ भन्दाखेरि 1 हो. So which is equal to यो 1 भने चाहिँ कति भयो? A भइगयो. So A intersection X is equal to A. अच्छा यो चाहिँ तिमीले रफमा कपी गर्न. बुझ्यौ? So what is A intersection X is equal to, that is your A. Okay? त यसमा आइडेन्टिटी एलिमेन्ट कुन चाहिँ भयो त? A intersection E is equal to A, right? Or you can write it as A intersection E is equal to A. This is possible only when E is equal to X. Is that clear? So this A intersection E is equal to A कति बेला possible हुन्छ? If E is equal to capital X. So I have shown you an example out here. You can copy it. Okay? So यो चाहिँ example हो. यो तिमीले देखाइरहनु पर्दैन. Directly you can write A intersection capital X is equal to A. So I think you have understood it now. So now, which is the identity element here? Since A intersection X is equal to A, so X is the value for E. So X is the identity element in P of X. Therefore, X is the identity element in P of X. Let in this case, not let, A star E is equal to E star A is equal to A, right? So either you can equate this first is equal to last or second is equal to last. That is A star E is equal to A. So it is defined as what? A star B is equal to A intersection B. So it is A intersection E is equal to A. So if you write instead of E, if you write X, then I just told you about one example, isn't it? I think you have understood it. So this A intersection capital X is equal to A. So in this case, X is the identity element in P of X. So I think you have understood it. Okay. So this is the answer for the first part. Okay. So this is answer for the first part. And again you have to show that in number 2, so that X is the only invertible element in P of X. So let us show it. So that capital X is the only invertible element in P of X. Okay. So this is for number 2. Now let us write here, let capital B be the inverse of capital A. Actually, this is the set B. Let set B be the inverse of set A. Okay. So now, you know that by definition, we know that. So by definition, we know that A star B is equal to B star A is equal to E. E means what is E here? It is capital X. Okay. Now A star B is equal to X, B star A is equal to X. When is this possible? यो कति बेला possible हुन्छ भन्दाखेरि यो यदि B मात्रै X भएर सपोज यो B मात्रै X भयो भने त A त यसलाई फेरि हामीले केमा लानु पर्यो? सरी, यसलाई फेरि इन्टरसेक्सनमा लानु पर्छ. That is A intersection B is equal to B intersection A is equal to X, isn't it? Now you can get the value for inverse. Okay. So you can equate either this first is equal to last or this second is equal to last. Okay, that is A intersection B is equal to X. Now if only you put B is equal to X, just now we see that A intersection X is equal to A. So B लाई मात्रै हामीले X लेख्यौं भने this relation does not hold. Okay, this relation does not hold. Is that clear? So if you write A as only X, X intersection B will be B. If A intersection X is equal to A, then X intersection B will be B. That will not be X. You should get it as X. You should get it as capital X. So both these A and B should be X. So this is possible only. This is possible only if capital A is equal to capital B is equal to capital X. That means in this case A pani X huncha, B pani X huncha. So X is the only invertible element in P of X. So we can write here, hence X is the only invertible. Hence X is the only invertible element in P of X. So this is proved. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 11. For all A comma B belongs to the set of natural numbers. Your capital N is the set of natural numbers. And we define A star B is equal to A cube plus B cube. Okay. So here the star operation is defined as A star B is equal to A cube plus B cube. Now we have to prove that this star is commutative, but this star is not associative. So let us prove it now. So here given here is A star B is equal to A cube plus B cube. So in order to prove commutative, you have to prove A star B is equal to B star A, right? So instead of A now you write B, and instead of B you write A, which is equal to, now on the right hand side also you have to write B cube instead of A cube and A cube instead of B cube. And you know that this A cube plus B cube is equal to B cube plus A cube, isn't it? You know that plus sign addition is always commutative. Okay. So if these right hand sides are equal, left hand sides must be equal. That is A star B is equal to B star A. So hence star is commutative. Hence star is commutative. So I think you have understood it. So let us prove that this star is not associative. And for associative, what is associative property? Within bracket A star B bracket close star C is equal to A star within bracket B star C. So let us find out first A star B star C. Okay. So which is equal to, what is A star B? You know that this is A cube plus B cube. So A star B is what? This is your A cube plus B cube. Then this is star C. So you know that this is A star B is defined as what? A cube plus B cube. And then star C is there. Now again you have to use the same expression A star B. Now let us take this A as A cube plus B cube. अब यो A के भयो, A cube plus B cube भयो, अनि B चाहिँ के भयो, C भयो. So what is A whole cube now? So what is A whole cube? This is actually here now A is A cube plus B cube. So यो A भनेको A cube plus B cube डल्लै हो. अनि यहाँ B भनेको कुन चाहिँ हो? C हो. ठीक छ? त A cube भनेपछि कति भयो? यो सबै A भयो. That is your A cube plus B cube whole cube. Then plus, what is B cube here? that is your C cube. So we got this A star B within bracket star C as A cube plus B cube whole cube plus C cube. Is that clear? So next, let us find out A star within bracket B star C. So let us find it now. So which is equal to A star is kept as it is. Now instead of A there is B, instead of B there is C. So also this becomes B cube plus C cube. So B star C will be B cube plus C cube. So I think you have understood it. Instead of A there is B, instead of B there is C. So since A star B is equal to A cube plus B cube, so this B star C will be B cube plus C cube. I think you have understood it. So now again, let us take A as A and B as what? B cube plus C cube. So which is equal to, now use this formula, use this definition, A cube is there. For A there is A cube. Then plus sign is there. Okay. So what is the value for B in this case? It is B cube plus C cube. So you have to write plus, what is B whole cube here now? This is B cube plus C cube whole cube. So I think you have understood it. So are they equal? You duita kaile equal huncha? Hudaina, they are not equal. That means therefore within bracket A star B star C, within bracket A star B bracket close star C not equal to A star within bracket B star C. भनेपछि हामी के लेख्न सक्छौं? Star is not commutative. So therefore star is not commutative. So star is not commutative. Star is not associative. Star is not associative. So star is not associative. So I think you have understood it. Okay. So in this case, we have proved that star is not associative. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 12. For all A comma B belongs to the R means real number. A comma B belongs to the set of real numbers. We defined A star B is equal to within mod A minus B. You have to show that star is commutative but not associative in this case also. So you can give the example also. So let us write down some particular real values of A and B. Okay, in order to show that star is commutative but not associative. So this A star B is defined as what? Within mod A minus B. Okay, so let us assume A is equal to 4 and B is equal to 3. Okay, so therefore A star B is equal to within mod it is A minus B. Or what is A in this case? It is 4 star. What is B here? It is 3, which is equal to within mod this is 4 minus 3, which is equal to within mod 1, which is equal to 1. Okay, so again let us find out B star A now. Now instead of A you write B star A is equal to within mod, what will you write? B minus A, isn't it? So it is B minus A. So or now what is B here? It is 3 star. What is A here? It is 4, which is equal to within mod you should write 3 minus 4, which is equal to within mod this is minus 1. Within mod minus 1 means it is always plus 1. Modular signs means it is positive. Okay, since 1 and 1 is there, so this is, we have proved that this 4 star 3 is equal to 3 star 4. That means A star B is equal to B star A. So therefore we have proved that A star B is equal to B star A. So therefore star is commutative. Star is commutative. So in order to prove star as commutative, we can give some examples here. That is A is equal to 4, B is equal to 3. You may give A is equal to 2, B is equal to 1 and so on. Okay. So now let us prove star is not associative. So here also let us give an example. For associativity, you have to give three elements that belong to the set of real numbers. That means you can put A is equal to 4, B is equal to 3, and C is equal to 2. Now all these elements belong to the set of real numbers. Now A star B bracket close star C. Let us find it now. So let us find out A star B first. So which is equal to, now let us put the value first. What is A here? It is 4 star. What is B here? 3 star. What is C here? That is 2. So which is equal to, now in this case, what is 4 star 3? Within mod 4 minus 3 mod sign close star 2. Is that clear? So which is equal to, what is within mod 4 minus 3? It is 1 star 2. Within mod 1 means 1 star 2. Which is equal to, what is 1 star 2 now? It is within mod 1 minus 2. Which is equal to within mod minus 1, which is equal to 1. So within mod minus 1 means its value is always positive. So you can write plus 1. Okay. So again you have to find out for associativity, you have to find out what A star within bracket B star C. So let us put the values of A, B and C. Which is equal to, what is A here? 4 star within bracket, it is 3 star 2. I think you have understood it. So which is equal to 4 star. What is the definition of 3 star 2? Instead of A there is 3, instead of B there is 2. So within mod A minus B. So it is within mod, this is 3 minus 2. So I think you have understood it. Okay. So now next, which is equal to 4 star within mod 3 minus 2 is 1. Which is equal to 4 star within mod 1 means 1. You know that, right? Now again, what is 4 star 1? You can use that definition. So within mod it is 4 minus 1, which is equal to within mod it is 3, which is equal to 3. So are they equal? This is 1 and this is 3. They are not equal. So therefore A star B bracket close star C is equal to A star within bracket B star C. That means they are not equal. They are not equal, isn't it? One is that is A star B star C is value is 1 and A star within bracket B star C is 3. They are not equal, right? So hence star is not associative. Hence star is not associative. Hence star is not associative. So we have proved that star is not associative. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 13. So consider a binary operation on q minus 1. So what is q minus 1? So you should understand the meaning of q minus 1. So q belongs to the set of rational numbers. You know the meaning of rational number? A number of the form p by q where q not equal to 0 is known as rational number. And here p and q are prime to each other. They should not have any common factor in between p and q. Okay. So q minus 1. 1 is not excluded in this. 1 is not included. This q minus 1 means 1 is not included in this rational number. That means 1 is excluded from this set of rational numbers. And it is defined by what? A star b is equal to a plus b minus ab. So in number 1, you have to find out the identity element in q minus 1. So what is the identity element in q minus 1? And in number 2, you have to show that for every a belongs to q minus 1 has its inverse. A को inverse छ भनेर हामीले प्रुभ गर्नु पर्यो अनि a को inverse पनि निकाल्ने. ठीक छ? So let's do number 1. Okay, so you have to find out the identity element in Q minus 1. Let E be the identity element. Let E be the identity element. So here this E should belong to Q minus 1. That is, E belongs to the set of rational numbers excluding 1. So 1 should not be included in this set of rational numbers. Okay, so 1 is excluded in this case. Okay, so now we know that by definition of identity element, we know that A star E is equal to E star A is equal to A, right? Now this A star B is defined as A plus B minus AB. Instead of A there is A, instead of B there is E. Okay, so how will you write down this right hand side? Now A is there, A is here, A plus B means E minus AB means AE is equal to, similarly what is E star A? It is E plus A minus EA is equal to A. Okay, but this LHS and RHS, these are the same expression. A plus E minus A is equal to E plus A minus EA, right? So either you can equate first is equal to last or second is equal to last. That is A plus E minus AE is equal to A. Is that clear? That is, you can equate first with last. That is A plus E minus AE is equal to A. So here A gets cancels. So what is common out here? E within bracket 1 minus A is equal to 0. Right? So what is the value for E now? So E is equal to 0 upon 1 minus A. Since 1 is excluded from the set of rational numbers, that means A not equal to 1 in this case. So A not equal to 1. Okay. If A is equal to 1, then this is meaningless. 1 minus 1 is 0. That is 0 by 0 is always undefined. Okay. So you can write E is equal to 0. So which is the identity element in Q minus 1? 0. So therefore 0 is the identity element. So 0 is the identity element. So I think you have understood it. Okay. So now let's do question number 2. Now what is question number 2 out here? You have to prove that for A belongs to the set of rational numbers excluding 1 has its inverse. यसको inverse छ अनि त्यो inverse के हो त्यो पनि निकाल्नु पर्छ. ठीक छ? So now let us suppose that let B be the inverse of A. Let B be the inverse of A that belongs to Q minus 1. And also B belongs to what? So B should belong to A Q minus 1. Okay, so let us find it now. So by definition of inverse, we know that A star B is equal to B star A is equal to E, right? So in this case, B is the inverse of A. Okay, so let us find out the value for B in terms of A. So now, or by definition, what is A star B? It is A plus B minus AB is equal to, what is B star A? Similarly, B plus A minus BA is equal to, what is the value for E in this case? Identity element is 0 in this case. Okay, and this LHS and RHS have got the same value, isn't it? A plus B minus AB ra B plus A minus B एउटै हो. That means either you can equate this first is equal to last or second is equal to last. So therefore A plus B minus AB is equal to 0. I think you have understood it. Let us get the value for B, or let us take this A to the right hand side. So here B is common, within bracket 1 minus A is equal to minus A, or what is the value for B now? B is equal to minus A divided by 1 minus A. So I think you have understood it. So which is the inverse of B? Minus A upon 1 minus A. So in this case, A not equal to 1. Since it is given 1 is excluded from the set of rational numbers. So that means A not equal to 1. Okay. So therefore we can write here, instead of B you can write A inverse is equal to minus A upon 1 minus A. So this is the inverse of A. So what is the inverse of the element A that belongs to Q minus 1? That is what? Minus A upon 1 minus A. So that is the inverse of A. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 14. This question number 14 is very, very important. So this type of question may be given in your HS examination. Okay. So this question number 14 is, let Q0, here this suffix is 0, Q0 or Q0. This may be read as Q0. So here what is Q0? Be the set of all non-zero rational numbers. Q is the set of rational numbers, but Q0 means here 0 is excluded. 0 is not included in this rational numbers set. Okay. And let A star be a binary operation on Q0 defined by A star B is equal to AB divided by 4. Okay. For all A comma B belongs to Q0. That is A comma B belongs to the set of non-zero rational numbers. Okay. So number 1, you have to show that star is commutative as well as associative. Okay. Here, number 2, find identity element in Q0, and you have to find out the inverse of an element A in Q0. So let us show number 1, that is star is commutative. So here what is given? Here given is A star B is equal to AB upon 4. So now in order to prove for commutative, you should prove A star B is equal to B star A. Okay. Now instead of A you write B, instead of B you write A, which is equal to BA upon 4. That means AB is equal to BA, you know that. That means both these are equal, isn't it? That is AB by 4 is equal to BA by 4. It is obvious. Okay. So therefore A star B is equal to B star A. That means what can you write? Star is commutative. Therefore star is commutative. So I think you have understood it. Now let us prove that star is associative. Again, now in order to prove for associativity, you have to prove within bracket A star B bracket close star C is equal to A star within bracket B star C. Okay. So now again we have here within bracket A star B star C. Let us find out its value. Now by question this A star B is defined as what? AB by 4. Let us write it here, which is equal to AB by 4 star C. Okay. Now you should take this A as, so here A cha, here ke cha AB by 4. So A can be taken as AB by 4 and this B can be taken as C. So which is equal to, now again it is AB by 4. A star B bhaneko AB by 4 cha, but here A is AB by 4 and what is B here? It is C. So what is AB by 4 now? A bhaneko kati ho? A bhaneko AB by 4. A bhaneko kati bhayo यहाँ? AB by 4, right? And B bhaneko kati, so what is B out here? It is C. A bhaneko AB by 4 हो. तो यहाँ A बनेको हामी के लेख्छौं? AB by 4. अब B बनेको यहाँ के छ? C. तो यहाँ हामी के लेख्छौं? C whole divided by what? That is your 4. Is that clear? This is actually AB divided by 4. Here A is AB by 4 and B is C. Is that clear? So which is equal to, now this is ABC divided by this 4 and 4 will be multiplied. That is your 16. So what is the value for within bracket A star B star C? That is ABC by 16. Now we have to find out A star within bracket B star C. Okay, so which is equal to, now A is kept as it is star. What is B star C now? So instead of A there is B, instead of B there is C. So on the right hand side also you have to write B instead of A and C instead of B. That is, this will be your BC upon 4. Is that clear? Now again compare it with A star B. Here A is equal to A, and what is B is equal to BC by 4, which is equal to AB by 4. So here A is A, here A is A only. What is the value for B here? BC by 4. Let us write it within bracket, BC by 4 whole divided by this 4 is constant. So which is equal to, what is the value now? You can multiply A by BC, this is your ABC divided by, this is 4 4s are 16. So here also we get ABC divided by 16. That means these two are equal. That is, you can write, therefore within bracket A star B star C is equal to what? A star within bracket B star C. So hence star is what? Associative. Hence star is associative. So I think you have understood it. So this is the first question now. Now what is the sub part here now? 2. So let us do this sub part, question number 2 of number 14. So now what is to be done here? You have to find out the identity element in Q0 or Q0. That is, Q0 means this is the set of all non-zero rational numbers. Okay. So now let E be the identity element. Let E be the identity element. That E belongs to the set of non-zero rational numbers. Okay. Now from the definition of identity element you can write A star E is equal to E star A is equal to A. Okay. Now by definition, what is A star B? It is AB by 4. Instead of A there is A, instead of B there is E. So by definition it is AB by 4. Here it is AE upon 4, which is equal to, now here instead of A there is E, instead of B there is A. So it is AB by 4 means EA by 4 is equal to A. And this AE by 4 is equal to EA by 4, isn't it? That is AE is equal to EA, you know that. So either you can equate first is equal to last or second is equal to last. So let us write here. So let us write here now, this AE divided by 4 is equal to A. So what is the value for E now? E is equal to A into 4 upon A. So I think you have understood it. AE divided by 4 is equal to A. Okay. So here A gets cancels. So what is E is equal to 4. So what is the identity element in Q0? That is your 4. Therefore identity element in Q0 is equal to 4. This is the answer. So identity element in Q0 is equal to 4. That is your answer. So I think you have understood it. Okay. So now let us do this last part, that is question number 3. Now you have to find the inverse of an element A in Q0. So what is the inverse of the element A in Q0? Okay. So let us assume let B be the inverse of the element A. Let B be the inverse of A in Q0. Let B be the inverse of A in Q0. Okay. Now by definition of inverse, you can write down that A star B is equal to B star A is equal to what? E. By definition of inverse, isn't it? Now next, what will you do now? or you know A star B is defined as AB by 4 is equal to, again B star A is defined as BA by 4 is equal to, what is E in this case? It is 4. So actually this LHS and RHS are same expression, AB is equal to BA. So AB by 4 is equal to BA by 4. So either you can equate first with last or second with last. That is AB by 4 is equal to 4. Or what is the value for B? It is 16 by A. Here A is not equal to 0. That means in this case, that's why Q0 is given as the set of all non-zero rational numbers. Non-zero rational numbers. That means A not equal to 0. Is that clear now? So therefore, you can write here A inverse is equal to 16 by A. So what is the inverse of the element A? Inverse of A is equal to, that is your 16 upon A. That is your answer. So I think you have understood it. So what is the inverse of A here? That is 16 upon A. So understood? So I think you have understood all the problems that we did today. So this much is for today. So you revise all the problems that we did today, and you also have to revise all the problems that we did in the last online class also. So today we have finished this binary operation. Okay? त जति पनि त्यो एचएस को क्वेशन पेपर र अस्सीहरु गरेको छौं त्यो सबै घरमा राम्रोसँग रिभिजन गर्नु. ठीक छ? जहाँ बुझ्दैन you can comment me or you can call me. Okay? तिमीले मलाई फोन पनि गर्न सक्छौ. म फोनमा पनि यी कुराहरु बुझाइदिन्छु तिमीलाई. ठीक छ? त जहाँ बुझ्दैन त्यहाँ चाहिँ सोध्नै पर्छ तिमीले. ठीक छ? त यो राम्रोसँग हेर्नु. राम्रोसँग हेरेन भने चाहिँ यो अप्ठ्यारो हुन्छ है बाइनरी अपरेसन. बाइनरी अपरेसन बुझ्यो भने एकदमै सजिलो छ, बुझेन भने एकदमै अप्ठ्यारो छ. ठीक छ? So this much is for today. So in the next online class we will do indefinite integration. त हामी 3 दिन अब indefinite integration गर्छौं अनि अर्को 3 days हामी गर्ने छौं vector algebra or 3 dimensional. Vector algebra र 3 dimensional geometry हामी सँगसँगै गराउँदै लान्छौं. ठीक छ? So in the next online class we'll do integration, right? For 3 days we will do integration, and for the next 3 days we will do vector algebra and 3 dimensional geometry. Okay? So this much is for today.